This is a new nozzle I designed for jet electrochemical machining. If you aren't familiar with how that works, I'll go over it quickly. Essentially, you have a workpiece, for example, a piece of aluminum, and you have a nozzle like this. And you apply an electric current between the two, and high pressure saline, so conductive liquid, shoots down from the nozzle, which you would want aniodic dissolution. So this will be the anode, and this will be the cathode electrode. And when the water hits it, you get a completed circuit, and it dissolves away some of the aluminum in that area. And what's really interesting about this method is that you can attach, say, this to a 3D printer, spray down saline, and micro machine aluminum just a few microns at a time. So if you wanted to etch images into aluminum or cut small channels into aluminum, or even cut, if you wanted to make custom PCBs by dissolving away the top copper layer of a PCB, you could do that. I've been running into problems with this electrode, and that is, let me go over this quickly. This is two nozzles, so it's sort of like dual extrusion. You can use two nozzles at a time. This would be a 1mm nozzle for a much wider saline spray, so if you wanted to cut wider channels, and this is a 0.2mm for much finer features. And they're just nozzles that are glued in here with hot glue, and there's epoxy connecting them to an aluminum tube. And the idea is you attach aquarium tubing, which is pumping the saline from a periostatic pump through here. Now the problem is I can't get a good seal with the aquarium tubing onto these barbs, and so as a result, saline is leaking out from the top, and then coming to the nozzle and then dripping off. And what happens is you have your nozzle and your workpiece, and you get a big like droplet in between the electrodes. And the problem is that this will all electrolyze at once because you have a much greater surface area of the electrode connecting to the droplet, connecting to the other electrode, so you get a lot of current through here. And this whole thing electrolyzes at once, and so now you have an explosive mixture of hydrogen and oxygen, and this whole thing detonates. And it ruins the workpiece, and it destroys the features that you're machining, and it, in my case, also destroyed the power supply because I guess this all converted to plasma, and then it became very conductive, and my power supply was destroyed. My power supply is a rectified, so 120 AC, and I convert it with a rectifier to 160 DC with also some capacitors in there. And so this nozzle will not work because I can't get a good seal, and now I also have to build a new power supply. I can get rectifiers off Amazon, so I can build a new power supply that way. But I have to figure out a way to connect these nozzles, these M6 nozzles with a 1mm pitch, to a 4mm aquarium tubing. Now, the problem with this is I think that the main problem is I need to find a way to get aquarium tubing, like a barb adapter or something made for aquarium tubing that'll be good for high pressure. So I have to figure out something on Amazon for that, and then I have to 3D print a new housing, and I also have to buy new nozzles. This is my last 0.2mm nozzle, and it's glued in place here. Another option would be to attach aquarium tubing to this aluminum tube and then maybe glue it in place or epoxy it or something like that. I think that wouldn't be a great idea, though. It's a temporary fix. I want something that will work and will be nice. One nice touch with this electrode, I thought, was you having these little screw terminals here. The problem with these is that they're very delicate and they fall off very easily. Soldering to these brass nozzles isn't exactly easy. Alright, that's it for this update.